Hello, everyone. So welcome to our second day. Well, it's the fourth day of the week, but it's our second day of webinars for OHD for Safe+Sound week. Thank you so much for joining us. I'm Stephanie Lynch. I'm OHD's Senior Technology and Research Manager. And then OHD is a supplier, manufacturer and supplier of safety and health equipment globally. And I'm joined here today by our marketing manager, Justin Lobdell. Say hello.
Hello, everyone.
Justin's going to be monitoring the chat, and he's going to let me know if there are any questions or comments. Feel free to drop anything in there at any point. We are so excited to be participating in this week. I want to send a shout out essentially to some of the organizers. So AIHA, ASSP, NSC, the acronyms abound.
OSHA.
OSHA. Really looking forward to the NSC conference in San Diego next month. Maybe I'll see some of you guys there. And yeah, NIOSH, OSHA, of course. So let's get started. Should have already had this pulled up. You'd think by the 1000th time you do a webinar, you would know that, but okay. So why do we care essentially about noise and sound and ultimately monitoring that? We of course want to protect the hearing of our employees, right? That's probably most of our jobs here, either industrial hygienists or safety folks. Helen Keller famously said that her blindness was what separated her from things, but it was her deafness that separated her from people. And I think that's just really profound, and I don't want to get too sappy here. But so once your hearing is gone, for most people, it's just gone. There's a lot of really good technology out there that can help you now, but it's expensive and it is still, surgical. That's dangerous. But so then you're left sitting in a room filled with people talking, and you aren't part of the conversation, right? So hearing loss is a really devastating disability, honestly. So there's also this important aspect of job satisfaction that can come from noise monitoring. So when people are exposed to noise, even that noise at levels which is not harmful, they can be annoyed. So essentially you can increase job satisfaction by, of course, reducing actual noise exposure if it is dangerous, but also simply by monitoring it. Showing that their exposure or annoyance is important to you can increase that job site. They can really feel like you care about them, and people do care. When their job cares about them, it helps them to care a little bit more about their job. Monitoring can also give you indications of maintenance issues. One of the first signs of equipment maybe really starting to struggle can be an increase in vibration and therefore noise exposure. And then of course, last but not least, we got compliance, right? So here OSHA is going to require that you implement a hearing conservation program whenever employee noise exposures equal or exceed an 8-hour time-weighted average sound level of 85 decibels measured on the A scale slow response, or equivalently a dose of 50%. So there you go, you got it, right? Okay. This is likely what each of you would be referencing for your noise monitoring. So it's what I will reference, although I am going to discuss some of the other options with how we monitor and interpret noise exposure. But while standards may be a bit confusing, and there's now just an abundance of different standards, community noise standards, building noise standards, construction noise standards, just all these different things. And they can be a bit confusing, but they are going to typically tell you exactly which equipment you need to monitor with and on what settings. So we're going to kind of touch on that a little bit. And then also there are people out there like me who can help you figure out exactly what you need to complete your noise monitoring. So hopefully this webinar can help clear up some of that confusion, right? Okay, so hopefully if you're interested in noise monitoring, then you're at least a little bit aware of what sound is. But just to brush up on the basics, sound is caused by pressure fluctuations around the static pressure. So for example, I am pushing air past my vocal cords right now, and that's causing them to vibrate. And that is then causing air molecules to move and transport energy. So that energy in the form of vibrations is then picked up by the receiver, so another person's ears, and ultimately interpreted as sound by our brains. So sound and noise for all monitoring purposes are the same thing. But in general, like a general distinction of how people define noise is that that is unwanted sound. So while wanted sound may be less annoying, it can still damage your hearing. So essentially, even if it's very pleasurable sound. So I've seen guys in a maintenance bay and they're going, using the radio to cover up what noise they're finding annoying, right? But it's actually the radio that puts them over the noise exposure limit. So what actually gets them to be overexposed. So it doesn't matter if you like it, it can still damage your hearing. Okay, as far as types of noise, in noise monitoring, we're going to divide it into 3 groups. There's continuous, variable, and impulsive. So continuous noise is defined as noise of a constant level with a duration of 1 second or more. Variable noise is that noise that's going to vary in intensity, also in durations exceeding 1 second. Continuous noise can also be variable. Impulsive noise is going to have a duration of less than 1 second. And OSHA is going to require that your exposure measurement include all continuous, intermittent, and impulsive noise within an 80 decibel to 130 decibel range, and that the monitoring must be taking place during normal work operations. So if your guys do typically listen to the radio in their workplace, then that's actually going to need to be a part of it. This is something that's important to communicate to those who you're monitoring. So I've also gone into helicopter maintenance bay and gone in to do my monitoring, and somehow I'm watching what they're doing. There's no real noise going on. I can't figure, I've been told that every year these guys are overexposed, and get to the end of the day, no one's overexposed. There's hardly any noise at all. And then when I talk to a couple guys, they're like, yeah, well, they told us to keep it down because we're doing the monitoring. So that's really something you have to communicate to people, that no, we want what the noise exposure really is, right? Because if we don't know about a problem, we can't fix it.
Sure.
So important to note there. People can be really confused. Also, always have to kind of assure people, especially if you do the personal monitoring, that you're not listening to what they say. I've seen guys just kind of talk into their shoulder where their dosimeter is, thinking that, I guess it's like a radio and I'm on the other end, able to respond in real time. Okay, so as if it couldn't get any more confusing, there are a lot of different terms when you discuss sound and noise. Just a couple that I kind of want to touch on is, so a time period. So during one period, a sound wave is going to travel a distance of 1 wavelength. And then so wavelength is a measurement of distance. So it's going to be measured in meters. And then period is a measurement of an interval of time. So it would be something that would be measured in seconds. The period is inversely related to the frequency, which is something we're going to talk about more in depth. But amplitude and frequency are completely independent features of a sound wave. So, well, anyway, amplitude is the maximum displacement of the wave about its mean position. So you're seeing how far that wave is getting from the center line there, and that's your amplitude. So a change in frequency doesn't change the amplitude of the wave, and a change in amplitude doesn't change the frequency of the wave. These things on the slide that I have, so it says, period, it's like pointing to frequency, they aren't equivalent to each other, they're just related. And that's just some little bit of foundational knowledge. If you really, really want to dive into noise, it's a whole thing. And again, I feel like I say this every time, but we could spend hours talking about sound and how we can talk about it and how we can explore what it's actually doing. But when you monitor noise, you're going to be looking at values in decibels. The decibel in normal use is really just referring to a degree of loudness, but technically it's a unit used to measure the intensity of a sound by comparing it with a given level on a logarithmic scale. So most popularly, the way to describe the magnitude of a sound is in sound pressure level. Due to the wide dynamic range of sound, it's easiest to do this on this logarithmic scale. The reference level for sound pressure level is the pressure threshold of hearing. Anything below this, and we as humans would not be able to hear it. We simply use decibels to make the scale of the numbers we're working with more manageable. By putting them on that logarithmic scale, it means that we can talk about them without having to talk about, the 10 to the negative whatever watt of power. So it's just a way of making it easier to talk about them. Okay, I said we were going to talk a little bit about frequency. Here we go. So sound is not exclusively characterized by that sound pressure level. A very important sound characteristic is the frequency. The sound's frequency is going to denote how many times per second that sound pressure wave repeats itself. The frequency of the wave defines the pitch of the sound. It's a representation of the number of cycles per second that the wave repeats. So the unit of frequency is the hertz. And so 1 cycle per second, 1 hertz would equal 1 cycle per second. So a wave that finishes the cycle in 1 second would have that frequency of 1 hertz. Just, you know, when you're having to look at this and you need to go look it up, just Google it again, right? You can figure out what that 1 hertz is. So in general, low frequency sounds are perceived by us as very bass-like. And I'm going to try something here, and it may not work because I'm going to play it from what we have here. Can we hear that at all? So I'm playing this 250 hertz. Let me turn my volume here and see if that helps. Wonder if anyone's getting that. I don't know if you can hear it, but so, okay. Low pitch, we're going to interpret those as very bass-like. And then hopefully you know that if you hear a high pitch sound, it's going to sound very, what's a good word for that? Sharp, maybe? Let's see if did anyone drop in the chat whether they actually are able to hear it? Oof, can you get that one? Delicious, yes. So that's our high frequency sound. So a low frequency sound is not going to have as many cycles per second as a high frequency sound. Subsequently, that low frequency sound is a longer wavelength and a high frequency sound is a shorter wavelength. So you may see frequencies also of 1000 hertz or above represented as kilohertz. And again, that's just another way that we make things easier to kind of talk about as we get into those higher levels. So we played those. Hopefully you're a little bit able to hear. Okay, a little bit more on frequency, getting into frequency weighting. So it's important to understand from a monitoring perspective, because of frequency weighting, like it's important to understand a little bit about frequency because frequency weighting may be required. OSHA is going to require that the monitoring be A-weighted. So A-weighted is interpreting essentially how we hear. The human ear is capable of responding to frequencies ranging from 20 hertz to 20 kilohertz. However, the ear is less efficient at both high and low frequencies, and then very sensitive in the range of 500 hertz to 4 kilohertz. The range generally considered the range of speech. So we're most sensitive where sounds are in that speech range. And it makes sense, right? Communication is a big part of our survival, essentially. So the A weighting mimics this. Noise monitoring instruments have frequency weighting to account for that. C weighting is going to place more emphasis on low frequency sounds, and it's most commonly used in applications like community noise monitoring. Z is when you want no weighting applied to the noise. I have it up there as 0 weighting. I, at this point, have no idea if that's actually a technical term. I think it's just what I used to help remember, but so Z, 0 weighting. Okay, and so this is how we perceive sound and that A weighting. So A weighting is going to be what you're typically monitoring when you're looking at an individual's exposure to sort of mimic how the human ear is feeling. So just to understand, I have different sounds up here. And so all of these sounds, let me make sure I can get I think my arrows are a little bit off, but you get the idea. All of these sounds are at the same pressure level. So here's that first one. Let's hope this works again. Oh, that's very low. Okay, y'all probably can't very well hear that. And I definitely don't want to play the 10,000 again. Here's our sort of mid-range. Hear that? So that and this. Oh, that's the same one. Here we go. So you see how much louder that sounds? Mm-hmm. So those are the same pressure level. all of these sounds, if you were able to hear all of them, you know, it would go from low to very high, but we would perceive those higher pitches as much louder, but they're actually all the same pressure level. Let's see how we're perceiving them different. Okay, so that's why you have to have that A weighting. Okay, another type of weighting that you're going to have to be familiar with when you start doing your noise monitoring is time weighting. So noise monitoring also has time weighting. They're fast, slow, and impulsive, and they're defined by the standards. And they determine the so-called speed at which the monitoring equipment responds to changes in noise levels. So for example, an instrument set to fast is going to respond quickly to changes in the noise level, whereas an instrument set to slow is going to respond more slowly. If the noise level is constant, both instruments will display the same level. An instrument set to impulsive will respond very quickly, because we mentioned that, you know, when you get to those impulse noises, that's the duration of under a second, right? And that's going to increase to a noise level, but then it's going to take much longer to fall when the noise level decreases. OSHA is going to require that slow setting. I have most recently heard that there is more of a push to have certain situations for workplace noise monitoring where you're going to have that fast response. And I have seen letters of interpretation from OSHA where they deem that acceptable. But I can't say that I know exactly, you know, which situations it would apply and which ones it wouldn't. So that's something you might want to look at. Okay. The good news about all of that sort of heavy noise knowledge, right? You know, and like I said, again, that's just the tip of the iceberg, just kind of some tidbits you kind of need to understand, or at least need to be aware exist, so that when you need to, you can educate yourself as necessary. But the good news about all that is that the instrument is going to collect all of that for you. So typically the first step in noise monitoring is to simply know what your noise levels are. So you just need to know which settings are best for you in your situation. And then this can be as quick as spot checking your sort of either loudest spaces or loudest pieces of equipment, to as involved as noise mapping your entire facility. Oh yes, and in the interest of full disclosure, OHD is the proud master distributor of the Svantec line of noise and vibration monitoring equipment. So that's what you're going to see here. And so now for noise monitoring with OSHA, you would want to reflect all the settings we just discussed. So you would want to know, you know, what sort of frequency weighting you're going to need, what sort of, you know, time weighting you're going to need. So we just said these things, right? OSHA is going to require that A weighting when you're looking at your employee's exposure, and then they're going to require the slow response. So just knowing those things. And typically with any noise instrumentation that you're going to purchase, it's at least they try to make it idiot proof. I personally have messed it up, so I can tell you that they haven't done it all the way. But while you definitely should know the settings that you need and why you need them, as long as you're testing to one of the common regulations, so OSHA, PEL, OSHA, hearing conservation, NIOSH, ACGIH, these are typically going to be able to be pulled from the software after the fact. If maybe you were only looking at OSHA at the time, but then afterward you're like, oh crap, I really meant to look at ACGIH or NIOSH. You can typically pull that from the software. I have recently discovered there are some settings that you may not be able to. So if all of your profiles are measuring in slow, you can't retroactively apply fast, for instance, or at least I think that's one of the most recent things that I've encountered. So you might want to be a little bit careful about that time weighted response, right? Okay, so sound level meters are not typically what you're going to use as far as your OSHA compliance. They may be, but the hearing conservation program is going to require that employers monitor noise exposure levels in a way that accurately identifies employees exposed to noise at or above 85 decibels, averaged over 8 working hours, or an 8-hour time weighted average. And this is not very easily done with a sound level meter. Your noise would have to be very constant and uniform, and your employee would have to be stationary. And so that's not it's not a very typical work situation. It does happen. They're what you would use to identify if you have a problem or to ensure that you don't have a problem, to select the appropriate controls once a problem is identified, or to identify maintenance issues with equipment, So these are more area concerns, right? So for instance, you would ideally perform baseline measurements on any new or existing piece of equipment and then check it regularly to see if there's a noticeable change. That change could be indicative of really a lot of things, but something as simple as a loose screw or a bad belt. And that sound level meter is going to help you figure that out. And so I'm sure that's exactly what it's like in all of your facilities. You got your job and they had a noise map of your entire facility that had been updated annually, right? No, absolutely not. They definitely didn't have that, and that's okay. You can go in and start wherever you can. And how do you eat an elephant? One bite at a time. So just go and find your most problematic area, do some area measurements there, figure out if you have a problem, and then go from there. If you identify that you do have a problem, then maybe you need to do some personal monitoring. Okay, so sound level meters, you can use those for your area monitorings. Technically can use them for personal, just some specific things you need to make sure are true. Okay, sound level meters are going to come in two classes. Class 1 or class 2 defines how precise that meter must be. Oh, it would help if I actually switch this on. That's going to help, not help, it will define how precise the meter must be. Which meter you're going to need is going to depend on what you want to use the meter for. So, or what noise you want to measure, what measurement regulations you need to meet, and whether your measurements will be used as legal evidence. And I say that simply because if you do want your measurements to be submitted as legal evidence, or you anticipate that they might be, then you may prefer a class 1 meter just for that increased accuracy. It's just, less margin of error, and why not? Like, you're never going to be wrong having chosen a class 1 meter for greater accuracy. But okay, so for an example, and I'm trying to think of a good one. Okay, there's a bunch of different standards, but so say you have and I can't promise these are going to be accurate, but say you have the 2005 control of noise at work regulation, and it states that a sound level meter should meet at least class 2 of the current instrumentation standard, so BSEN 61672, whatever, or at least type 2 of the former standard. Now it's going to write it in some way like that. That's going to make it probably as confusing as possible. But all that really means, if it has to be at least class 2, then you're good with class 2 or class 1. If you're working on an environmental noise standard, then it may specify the instrument should be class 1. So one of the ones that we have to look at with airports may say that it shall conform to the electroacoustical performance specifications of IEC. I'm never going to get those numbers right, but you get what I'm saying. It's going to put it, the standards out there are going to tell you exactly what you need to use. They just are going to state it in what's going to seem like a very complex way. So just, pay attention. And if it says specifically class 1, you definitely need class 1. If it says just at least class 2, then you're good with a class 2 monitor. So it depends on, what are you willing to invest and what are you measuring? And so these are the areas of which those class 1, well, I didn't mean to skip that, but that's fine. It just showed you the bandwidth where class 2 was wider, right? It had a wider range that it was able to go to, whereas class 1 had a more narrow range. So it's just measuring a little more precisely, maybe a fair amount more. Okay, this is less likely to be an aspect of compliance, but it is relevant when you need more detail about your noise. So we talked about frequency weighting on your instruments, and we got to listen to a couple of those different frequencies of the same sound. That's not typically what people would be exposed to at work. Noise measurements are actually often going to include a very wide range of frequencies. So to provide frequency-specific information about a noise is going to help in doing things like designing control measures, whether that's barriers or enclosures, or whether you're going to implement maybe some acoustic tiles like we just are trying to do out front, to the selection of whatever hearing protection you might want to use. This is where octave bands are going to come in. Octave band analysis is concerned with measuring both the volume of noise in an environment and the frequencies at which those noises occur. So single octave band analysis may not offer enough resolution for many of these purposes that I just listed. So the next step would be third octave analysis. And these are what you're typically see offered on your instrumentation. So this can go all the way to 12th octave. So you see that you can get quite a high level of resolution. And so like 1 to 1 is less descriptive, right, than 1 to 3 and so forth and so on. Okay, when you do a noise survey with your sound level meter, now that you know all about sound level meters and a little bit about the settings you need, you can go out and perform that preliminary noise surveillance, noise monitoring. So remember that that's your area monitoring when you're using that sound level meter typically. So with area monitoring, location is everything. Make sure you consider things like the reflection off of yourself and also any sort of vibration or reflection off of any surrounding equipment. So also remember the purpose of whatever measurements you're making. This sounds like it should be pretty common sense, but I've personally just done that several times where I really measured somewhere that I really didn't need to. So for instance, if everyone works in a certain area, but there's this space behind the stairs, and I'm just thinking, well, I better get that space behind the stairs, but if no one ever goes there, it's not very practical to measure there. If you're concerned about noise levels in an area where people are working, you might not need to measure behind a piece of equipment, essentially, where no one works. Make sure that you calibrate before and after each use. OSHA leaves this pretty vague. It says something like employers check or calibrate your instruments or follow manufacturer, whatever, but they want, and essentially you have to ensure that your measurements are accurate. So I get that that's very vague language, but it really is best practice to just pre and post calibrate. So go ahead and do your essential bump calibration before you go take some measurements, and then go ahead and do that bump calibration afterward. Just make sure your instrument is working appropriately and doesn't have a lot of drift. That'd be what you're looking out for. If you do see a lot of drift, then you may want to have that instrument serviced. Okay, noise dosimeters are technically just a specialized sound level meter. They're worn by a worker and they measure their personal exposure. They're now very light and they can be very easily worn all day. These are what you're typically going to use for your employee personal monitoring to define their exposure. And this is what you're normally going to do for that compliance with OSHA. So personal monitoring, if you already know that you have a problem, or if area monitoring reveals a possible noise hazard, or if you just want more individualized data, you move to personal monitoring. This can also be what is more appropriate depending on how mobile employees are and whether the areas they work have significant variations in the sound levels, or if the employees are exposed to impulsive noise. These are much more likely scenarios. That's what I meant when I said that it's difficult to do this with a sound level meter, because you want the data to be representative. So employees moving from space to space and being exposed to different types of noise, you would have trouble doing that with a sound level meter. So as I've mentioned, this is the better way to comply with OSHA to accurately identify an employee's exposure. Another term or concept, I guess, that you need to be familiar with once you move to personal monitoring is noise dose. So noise dose is directly related to the standard you're referencing, which is very frustrating, but it's a function of how much time you spend at a sound level as compared to how much time is allowed by the standard or regulation or recommendation that you're referencing. And we're gonna dive a little bit more in that. I'm gonna try to make that like a little bit more clear. Okay, so if you're looking at this slide, and I actually don't know, are y'all able to see the mouse if I do this? So if you look over here at OSHA's exposure level, they use a 5 decibel exchange rate. That 5 decibel exchange rate is going to define how that organization is defining noise doubling. So OSHA has a 5 decibel exchange rate. So when you go from 90 to 95, you're saying that that noise exposure has doubled. And so that means that your employees are getting double their dose. And that's what reduces your time by half. And so this is going to kind of show a little bit of why you have these different regulations with their different settings, essentially. One of the big ones is that exchange rate. So if you look here at the NIOSH recommendation, so this is their recommended exposure level, the REL, theirs is a 3 decibel exchange rate. So they're saying that at 85 decibels, you're allowed to be exposed to 8 hours. But then when the noise doubles, that 3 decibel exchange rate, and goes up to 88, you're only allowed 4 hours of exposure. And so you can see when you switch from OSHA and you start trying to go above and beyond to go ACGIH or NIOSH, you're very quickly going to see a big difference in what noise exposure is allowed. And it's going to change the exposures that you've been seeing if you've previously been monitoring with OSHA. So you can see that OSHA, you go all the way up to 115 and you're still allowed 15 minutes at that exposure level. Whereas when you switch over to NIOSH or ACGIH with that 3 decibel exchange rate, by the time you get to just 100, that's where you're only allowed the 15 minutes of exposure. And again, I know that this can be very confusing, so we really are going to try to touch on it just a little bit more, right? Okay. So this is where, or I guess also where some of the benefits of measuring on multiple channels or profiles is going to start to show. Noise dosimeters are going to allow you to measure with different settings simultaneously. So the OSHA PEL and the OSHA HC, hearing conservation, so OSHA permissible exposure limit, OSHA hearing conservation settings are more common channels to be preset on noise monitoring equipment. But usually you'll see one of these other ones too. So either ACGIH, NIOSH. There are certain aspects of noise monitoring that may want you having more than just those 2 OSHA compliant ones. And it's kind of like, so I'm going to use the NIOSH ACGIH on here because I know that's the one that can confuse people. So why would you measure with a setting that you are not required to use? Well, that's because the settings more closely follow how sound and noise actually behave. Also, nearly a quarter of workers that are exposed at OSHA's allowable limit will still experience hearing loss, whereas this drops significantly, so to below 10%, with the implementation of a limit of 85 following a 3 decibel exchange rate. So you will be better protecting your people if you do follow ACGIH or not. Okay. So we're gonna talk about just a little bit more, just to really get this in, because it is an interesting concept. So the exchange rate is that increase in noise level that corresponds to a doubling of the noise. This is important because when that noise doubles, exposure doubles. And how a standard defines this determines how much time an employee can spend exposed to that sound. And this is because of how noise actually functions and because of us using that logarithmic scale to discuss noise. So using that decibel system. So 85 plus 85 in noise does not equal 170, which I hope is what 85 plus 85 is. Oh, okay. So it actually equals 88. And that's because noise doubling in that logarithmic system, like I mentioned. So this is how noise is actually behaving out in the real world. Okay. So those were 2 sounds that were identical, 85 and 85, correct? So these are how you add decibels if, say, they weren't, which again, much more likely to be the real scenario, right? The chance of you having 2 pieces of equipment that are putting off the exact same sound level is highly unlikely. But so these are how you actually add decibels. And once you get to 10 decibels of difference, you don't actually have to add anything to double the sound. It's just going to be the highest sound level that's present. So, but when they're close, you got that 3 decibel that you're adding to it, exchange rate. Okay. Once you do some monitoring, and I hope that was just, do we have any questions right there? Okay, we're good. Okay. Once you do some monitoring, or as you are monitoring, you're going to see a value displayed, and this will often be the L, and it'll either say EQ or LAVG. So LEQ is the equivalent continuous sound level. This is the most commonly used value to describe sound levels that vary over time. And LEQ is the level that would produce the same sound energy over a stated period when using that 3 decibel exchange rate. LEQ is always based on an exchange rate of 3 because that's how sound behaves. For other exchange rates, the average level for the measurement duration is known as the L average. So LAVG is how you'll typically see that. So in the US, the exchange rate as defined by OSHA is 5 decibels. So here it becomes a very important measurement, that LA average. So using that 5 decibel exchange rate, the 8-hour average level is known as that time weighted average. We also already touched that. Okay, so those are all just because you're using that 5 decibel exchange rate. Using that 5 decibel exchange rate, the 8-hour average level is known as that TWA. This can also be reported following the 3 decibel exchange rate, but for compliance purposes, again, we would just be looking at this. Oh goodness, sorry guys. For compliance purposes, we would just look at one example with OSHA, and this is what they would expect you to accurately identify, essentially. So the important thing there is just that's what's required by OSHA. Okay. So after you've set up what you want to measure, these are some of the actual physical steps. This is by no means an exhaustive list, and a lot of this is intuitive. However, for the first several noise surveys that you do, I highly recommend bringing a checklist. This is in addition to the information you're going to collect as part of record keeping, which will come out of your reports. Absolutely check your batteries, bring an extra dosimeter or two just in case. Pre-calibrate and replace your windscreens. Ideally, your employees are used to being monitoring and there's an atmosphere of trust, but this starts with a clear explanation of what you're doing and why, and setting expectations of them, right? Explaining how you really do want to see representative work, and you want the noise to be how it just normally is. So place that dosimeter in the hearing zone. So that's defined by OSHA. I think it's like, there's like a circle that they draw around the head. I can't remember the exact distance, but usually up on your shoulder, you're fine. We have some, or we used to, that would go up on your hard hat. Those are both acceptable places to put your dosimeter. But once the dosimeter is deployed, don't constantly interrupt that employee, right? You want to just let it go. Because like we said, we want it to be representative of that employee's actual work. So let them get on with their job. That's another thing, thinking about, worrying about if your settings are correct. You know, you should be taking the time beforehand to get familiar with your dosimeter, get them set up how you want. But so if you at the very last minute after you've got this thing running, realize that you wanted it to display ACGIH and you left it on OSHA, well, just don't worry about that. You're going to be able to go into your settings later. You're still going to be able to look at that. Just leave it. Many dosimeters also have Bluetooth capability. And that means you can check on the results or your battery life from a discrete distance. You can also take photographs that you can add to your report, and that's going to help provide some context to any notes you might make. If you do see something interesting, you can approach the employee, and the dosimeter will let you make a little noise, like a little audio recording about that noise. So say something strange happens that's really out of character that creates a loud noise. I'm trying to think of a helicopter lands on the roof, and that's not something that normally happens. Well, you can go over and go, hey, helicopter landed, whatever. You're also going to be able to check that noise later. When you see that high noise, we'll get it that way. Look at the software, but you should already have these set up, and don't worry if you think you have the wrong ones. It's going to calculate on multiple parameters simultaneously. So you should have that data in the form that you need. Okay. So a cool thing about Symantec software is the relatively new Supervisor Lite option. So Supervisor has incredible functionality, but it offers super high levels of data analysis and interpretation that are well beyond what you or I, as an IH or safety person, might need. They're more, maybe an acoustical engineer might be really stoked to have all that functionality, but we might not need it. So Supervisor Lite is a much more simplified system to view your noise monitoring data. It also introduces a new function, the validation tool. And so that's a module that allows for quick and easy validation of the results by moving erroneous data, such as invalid noise sources, mechanical shocks to the instrument. So, like if it gets bumped or dropped, interpreted as sound or acoustic impulses. and data gathered when the dosimeter wasn't being properly worn. So like there's an alert for if it just remains stationary, like sitting on a desk. So I think this will kind of show some of those. I'm not sure exactly how well you can see this. I can't see it great, but it's going to tell you on the left-hand side. It also looks like it's maybe a little bit cut off, but on that left-hand side, it's going to tell you what sort of audio event took place. So here you can see that what happened was there was a no motion, event. If that ends up happening, here it doesn't say that that's what happened, but I'm just saying you can go in and you'd be able to take out those sections of time where the monitor was very clearly not being worn. And then for some of these other audio events, if it got bumped, if there was some sort of high vibration thing that happened, essentially you could go in and you'd be able to see where that noise was. You could listen to what it's saying, and then you can, if it's not relevant to what you're trying to measure and it's not a normal part of the employee's exposure, you can go ahead and kick it out. And so it gives you that functionality, and it's pretty cool. So this is a report, like something you could just typically see. And the only thing I really wanted to show here was kind of what ends up happening with dose when you look at work schedules that are not maybe typical. So if you come down here, and I only did, a quick measurement on this, but essentially if you come down here and you've got your standard day of 8 hours and you're only at that 91% dose, well, if you roll into a 12-hour day, now your person's overexposed. So shift work, or if you're on a different schedule, that's something you need to consider as far as how your exposure might need to be interpreted. So you make sure that you're protecting your people, right? So these are some of the most common reasons that I've seen for getting inaccurate data. So maybe the dosimeter is placed under a collar, or it's too close to the employee's face where like a beard could rub it. That's something that I've seen. The employee either intentionally or unintentionally impacts the results. I'm trying to think of all what I haven't mentioned. I've had a music teacher who placed her dosimeter away from the music because she thought it would, cause interference. I've had a guy turn up his music in his car on his lunch break, which with how my dosimeter worked back then, I had no ability to figure out what was going on. So it took me forever because, they expect one IH or one noise guy to go out there for, maybe 5 or 10 people that you have to monitor. So you can't have eyes on all the time. So it just becomes kind of tricky. You'll catch people whistling or yelling into the dosimeter. You now have the ability to go in and look at that event and make sure that it is something that should be applicable to the employee's exposure, right? So sometimes a person won't be working where they typically would. So they might think that you want lower or higher noise levels. It is interesting if you don't communicate well. Like I said about that hanger, the guys thought that we wanted low levels of exposure, but the opposite can happen where someone can think, oh, the company paid for us to get hooked up with these monitors. We should go make sure they get the worst case scenario of all this awful noise we have in the plant. You may have selected the wrong person for a particular area. So someone who's maybe not really representative of the group that you're trying to establish as a similarly exposed group, but threshold distortion can happen when the noise levels hover right around the threshold, and that can cause the dose and time weighted average to be low. Your windscreen should always be in place, but just know that wind that exceeds 12 miles per hour can cause more sound energy to be picked up than was present. Battery and calibration just go without saying. If you haven't pre and post calibrated and then you see something weird in your data, you're gonna have no idea if that was part of the problem. And always make sure that your batteries are well charged, because boy, that'll really get you if you get over there and you don't even have battery power. So our customers are typically regulated to perform noise monitoring, but just for the record, there are a lot of other very good reasons to perform noise monitoring. You may have an annoying neighbor. No, okay. Selecting the correct hearing protection is dependent on knowing what the exposures are. Correctly utilizing hearing protection can reduce workers' comp claims and therefore insurance costs. Implementing engineering controls can also reduce costs. And sometimes it actually is as easy as performing some maintenance. So the noise levels can just kind of creep up on you if you've had this piece of equipment forever. And maybe, a few years ago you had checked and everything was fine. But you might not notice it's gotten too high unless you are regularly monitoring. So engineering controls can then reduce reliance on hearing protection, which can reduce the cost of hearing protection itself. and of the hearing loss and the subsequent claims. It's all connected. So effectively reducing noise exposures based on monitoring can also improve productivity. It's going to improve communication in your facility. You're going to have employees who have better concentration, and then also safety. I mentioned that the range of noise that we're most sensitive to is that speech range, and that's because communication is so important. So safety, employees are going to be able to hear each other and hear any warning signals that you may have. It can also allow for continued operation. For instance, if your community has implemented some sort of noise, like a noise guidance, I don't know, for their community. Essentially, you're going to be able, if you get noise levels down low enough, you're going to be able to operate for longer hours if you have your noise levels down to where they're not over whatever limit. So you can actually get more productivity. Okay. So, and I just think that's kind of an emerging issue with noise. All right. So is everyone confused enough? Do I have any questions about anything that we've discussed?
Yeah, we do have one. So someone asked, what about humidity levels, such as in a food processing plant? Like, will that cause any issues with the actual readings?
I've never.
Or have you ran into anything like that?
I've never run into that. And I mean, I'm in Alabama, and it's stink nasty humid in here. So sometimes, and so I've never seen that have an effect. And as I'm sitting here thinking about it, I can't imagine why it would.
Great.
All right. Well, we appreciate all of your time. We really just enjoy doing this. This is our 3rd year participating, and we've got another webinar tomorrow. That'll be on heat stress. And pun intended, it's just such a hot topic right now. So we're looking forward to that. And that's how we're going to close out our week. And if you do have any questions, just, let us know.
Yep. And keep an eye on your inbox. We will be sending you guys an email probably tomorrow, and it will include all of these PowerPoint slides for you guys to use at your own organizations, as well as a link to be able to view this live recording as well. And we did shoot you guys a quick question, a quick poll. So if you wouldn't mind just taking that real quick before we sign off. And as Dr. Lynch stated, feel free to reach out if we could ever give any assistance. So thanks so much.